Okay, today we're doing 9.3 solving quadratic equations by graphing. The good news about this lesson is it's graphing and we did that in 9.1. So it's more practice with it, but there's nothing really new as far as information. Um, we're going to look at these graphs and see where they cross the x-axis because where they cross the x-axis will be our answers. So, a quadratic equation is an equation in the form of ax squared plus bx plus c equals 0. And the solutions of a quadratic equation are called the roots. To find the roots, graph the quadratic equation and find the x-intercepts, or you can call them zeros. So roots, x-intercepts, zeros, they all kind of mean the same thing. So when you graph, you're going to end up with something like this, or like this. So some of them, a lot of them, you'll see have two places that it crosses the x-axis. Then that means that there's two solutions. If it just touches it, if the vertex is on the x-axis, then it just hits it once, that's one solution. And of course, if the vertex doesn't even ever touch it, those are the ones where you have the range of y is greater than or equal to 1, then it's never going to hit 0, then there's no solution. Okay? So those are the three different types. And I'm going to do two problems of each for examples, and I hope I kind of go through this one quickly because the 9.2 one I did was 17 minutes long or whatever. I would like to make these a little bit quicker than that for the sake of you and me. So let's start with this one here. X squared minus 2x minus 8. There we go. Remember how to graph these? So this one is going to be opening upward, okay? Because you have a positive. It's not negative in front. So we're going to open upward. I'm going to mark I think I'm going to not use black for one, but I'm going to mark the y-intercept, which is negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. 3 down here. And then I want to find the vertex. If you remember finding the vertex, you go negative b over 2a, and that'll get you your x value of the vertex. So negative b is a positive 2, 2 times a, so 2 times 1, so 2 over 2 is 1. So 1 is my x value of my vertex. To get the y value, I need to plug it back in for my x's here. So 1 squared is 1, minus 2 times 1, minus 8. So 1 minus 2 is negative 1, minus 8 is negative 9. So that means my vertex is 1, negative 9. And now that's also, remember the axis of symmetry here? So this point is going to be symmetric. And now I have a kind of a general idea. The problem is I don't know exactly where it crosses up here. And those are the points we need. So we need to make kind of an XY table and give ourselves an idea of what number to put in so that it crosses the x-axis. I have, let's see, I'm going to put in a 3. So I'm going to put 3 squared is 9, minus 2 times 3, which is 6, minus 8. Well, 9 minus 6 is 3, 3 minus 8 is negative 5. So that means that's right here. Let's try a 4. If I put a 4 in, 4 squared is 16, minus 2 times 4 is 8, minus 8. Oh, look at that. That's 0. So 1, 2, 3, 4, 0. It crosses right there. Now be careful when you plot the other one. Make sure you're using the axis of symmetry and not like the y-axis. So this is 3 away from the axis of symmetry. It's 3 away right here. I'm going to draw this, maybe. And my answers are actually going to just be the points where it crosses the x-axis. So this point and this point. So my two answers are going to be -2 and 4. We'll do another one. Here we go. This one, we have to put it in the correct form first. Okay, so we just don't have a 0 over here, so we need to add our 6x to both sides so that we can have it in the correct form. So I will be working with -2x squared plus 6x plus 8. Okay, and that's going to equal 0. So I'm going to start graphing this. I think I'll just plot my y-intercept first. 2, 4, 6, 8. I know it's going to open down because of this negative, and I want to get my vertex. So negative b would be -6 over 2 times -2. So I have 6 over 4 or 3 over 2. So that's 1.5. And then I'm going to plug that 1.5 in to get my y value of my vertex. Okay, I had to throw that in my calculator, but I got 12.5 after I plugged it in. Okay. So my vertex is at 1.5 and 12.5. So this was 8, 9, 10, 11, 12. So right about here. And then I'm going to plot. This point is 1.5 away from that. So symmetric would be right there. And again, I got to kind of estimate where I think that this is going to be. So why don't I plug in a -1 and see if that works. Let's do that. If I plugged in a -1, I'd have x squared would be +1 times -2 would be -2. I'll just write it down here. -6 plus 8. Oh, look at that. That equals 0. So -1 is one of my answers. And I'm just going to, that's my axis of symmetry there. This is 2.5 away there, so it's going to be 2.5 away here. Well, that's fun. Oh my gosh. I think it's time to go to bed because that looks terrible. But the point is, -1 and 1, 2, 3, +4 are going to be our answers. Ta-da. This one here this one is going to probably have one solution. So let's take a look at it. We're going to start plotting. We have -4 for the y-intercept. We know that it goes down because of the negative out front. So I'm going to put a -b over 2a to get my vertex. So -4 over -2. So I get 2, and I'll plug that in. If I plug it in, I have 2 squared is 4, negative in front, so -4 plus 8 minus 4, that actually gives us 0. So my vertex is going to be 2, 0. And I know it opens down, so I know this point is over here, and my graph kind of looks like this. Okay? So our answer is just going to be wherever it crosses the x-axis. Well, in this case, the vertex just touches it once, so we just have one answer. X equals 2. We'll go on to this one. Again, we have to add that 9 so that we have a 0, set it equal to 0. And 9 is going to be my y-intercept. 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to go negative b, so positive 6 over 2. So I have 3. And if I plug in a 3, I get 9 minus 18 plus 9. Look at that. I get 3, 0, which is my vertex. It opens up. So this is my line of symmetry. It's going to go look like this. And my answer is just going to be x equals 3. Those ones are easy. I think they're easier. But we don't know until we graph them how many solutions they're going to have. These next two are going to have no solutions, so I'll show you those. This one, okay, I have to subtract my 5 first, which is fine. All right, so 1, 2, 3, 4, 5 for my y-intercept. My vertex, I'm going to have negative b, which is a positive 3, over 2a, negative 2, so I have negative 1.5. So I plug in that negative 1.5, and I end up with negative 2.75. So when I do that, I get something like right here for my vertex. I know it's opening down, and so it looks like it's gonna be something like this. But the point is, it will never ever cross your x-axis. So you have 0 solutions. So you have no solution, or you can write the symbol like this. Okay, so there's no real solution on this one. This is another one that should be done the same way. In fact, if I go ahead, I know it's going to open up, and I know I have my y-intercept at 14, so that's 4. 14, now that's way the heck up there. My vertex, I'm going to have negative b over 2a, and if I plug that in, okay, when I plug that in, I got 1.75. Okay, so negative 3.5 and 1.75, something like this. We know it opens up, and this is my y-intercept, this is my vertex, so we will have another point over here-ish. And again, it doesn't cross the x-axis, so this is no solution. Good luck, and we won't be graphing so much anymore the rest of the chapter, so at least you can be happy with that. I think I'm giving you a worksheet, but you don't have to do the work on the worksheet. You can do it, but I just want those problems because the ones in your book, they have messy vertexes and stuff, and I think the ones on the sheet are a little bit nicer, so that's why I gave you that. Let me know if you have questions. Talk to you later.